Hello. I am live. Hopefully, we don't have any issues with the sound not working today. So, the question of the day is if you could pick a celebrity to play you in a movie, who would you pick? So, pick any celebrity to play you in a movie, who's it going to be? Type it in the chat. If you. So, the question of the day if you could pick a celebrity to play you in a movie, who would you pick? So we'll give everybody a couple minutes to jump in, and then we'll get rolling here. Looks like the snow is starting to melt. Thank goodness. I woke up this morning and about lost my mind because there was like 2 inches of snow, and it was like 80 degrees the other day. So it was absolutely crazy that we had snow today, but it looks like it's starting to melt. Let's see what the weather's supposed to be like today. 37, high of 42 today. Not quite where I'd want it to be yet. We need to warm up a little bit more. Actually, let's see here. It's supposed to be 60 degrees on Monday, 55 on Sunday. Not quite warm enough yet, though. But it was seriously like 80 degrees the other day. I'm just looking at the Weather Channel here. It looks like next week we're going to get into the like 50s and 60s, but still not summer yet. I think if it were summer, it'd be a little bit more bearable. The snow this morning was a rude awakening. So, again, the question of the day is if you could pick a celebrity to play in a movie, who would you pick? So, we'll wait about another minute or so, and then I will reveal my choice, which you might be able to guess. Do, 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 do. I am super excited to cook dinner tonight. Cooking is like my new pastime, and I am making Parmesan roasted cauliflower and easy honey garlic pork chops. We subscribed to this. Like none of the grocery stores have produce, and there's this service called Imperfect Foods, and they will send you a box of just like random vegetables and stuff. And it's not expensive either. You'd think that like shipping vegetables to you would be expensive, but it's really not. It's like $20, and they send you a whole box of just random produce, and which is kind of cool because you have to figure out recipes that'll work with what you get. And I got beets last week, which I ended up putting in a salad. I got a cauliflower this week. Not my favorite vegetable, but I'm gonna jazz it up a little bit with this recipe that I found. It sounds amazing. So we'll give this a whirl. And then, like, when we were buying meat a couple weeks ago, like, pork chops were the only thing we could find. So I'm going to try to jazz up a recipe and see how it goes. I'm a vegetarian. I don't actually eat meat. So I'm just trying to keep my family happy, excited about food. All right. So looks like it's one of those days where people are still sleeping in because I only have one viewer today, which is fine. It's fine. It's totally cool. Doesn't hurt my feelings at all. Just like normal class. I have a whole classroom full of people, but there's usually only like 3 or 4 people paying attention. Everybody else is, doing the whole like phone thing. So that's fair. All right, if I could pick an actor, I would pick Bryan Cranston. So I've kind of got the goatee going on here. Kind of have the same hairline as him too. He played Walter White in Breaking Bad, which is one of my favorite TV shows of all time. He's a little bit older than me, actually quite a bit older than me, but I feel like he could do a pretty good Mr. Zord. So we'll see. If they ever make a movie about me, he would definitely be the person I would pick. Okay, so for this week, we are working on some magnetism stuff, and what you were supposed to do today was to play around with the magnetism FET simulation. Okay, so what I'm going to do today is I'm going to go through how the simulation works and kind of go through a little bit of the lab, and I'm going to give you a preview of something really cool that you get to see tomorrow. So let me pull up the simulation. Now, when you click on the link that I posted on my website. It brings you to a page that looks like this. All right. And usually with the other PhET simulations that we've used, you've just been able to click on this button and it'll load it. However, this is an older simulation and you actually have to download this to your computer. So I'm going to save it to my computer. And there's instructions on how to do this in the Google form for today. But then you just click on this link down at the bottom and it opens it and it looks just like this. Okay, so there are two simulations in one here. The first one is a bar magnet, which is very similar to what we did the other day when we were playing around with things. So actually, let me pull up the Google form that you had to do today, and we'll kind of go through the answers together. The Google form today that you had to fill out was a little different because it was fill in the blank. It was not fill in the blank, but free response instead of multiple choice. So the first question was, move the compass around the magnet, explain what happens as you move it. Use terms like north, south, red, white, attract, repel in your answer. Okay. So if you notice right now, the red end of the compass is pointing towards the south pole of the magnet. Okay, now if I bring it to the other side, notice the white end of the compass points towards the north end of the bar magnet. So like you have to have a red end pointing towards a white end. You'll never have like the red end of the compass, the red end of the compass pointing towards the red end of the bar magnet. So remember, just like we talked about with electric particles and charges, opposites attract. So you have a white end attracted to a red end, a north pole attracted to a south pole. Okay, so as I move my compass around, notice the white end is still pointing towards the red end of the bar magnet, but when I get to the other side, they kind of switch. So now, since we're closer to the south pole, this end of the compass, the north end of the compass, is now pointing towards the south pole. So I'll go slow, and you can watch as it transitions as I go around the bar magnet here. So right about here is where it flips over. So now the south end of the compass is pointing towards the north end of the bar magnet. Okay, so the next question that you had to answer was about the strength of the magnetic field. Okay, so what I'm going to do is I'm going to take my field meter. So I'm going to check this box right here, and I'm going to bring my field meter out onto the window like so. All right, and then the question that you were supposed to answer was drag the sensor around the magnet. Where is the magnetic field the strongest? So when we're looking at the strength of the magnetic field, we're going to look at the very top row. Okay? It gets a little confusing what these other things actually mean. So we're just going to like pretend that they don't exist, and we're just going to look at the top row. Okay, so let's go around the magnet and let's measure the field. So notice it's pretty much about the same. As we get down here in front of the magnet, it's pretty strong. So we're reading 1.69. And I'm going to try to keep the same distance around the magnet. So we're about 1. And then when we get to about here, it's kind of about the same, 1.69. So directly in front of the poles of the magnets is where our field seems to be the strongest. Okay, or in close proximity of the magnet here. So it's about 1.69 here, the same distance. It's a little bit stronger here, but I guess right out in front of the poles here is where it's the strongest. Okay. Now the cool thing about the simulation is it's got these little compass icons on here. So if you look out here, you can see that the compass icons are a little bit dimmer. So it gives you a good visual of how the strength of the magnetic field. The brighter the compass icons, the stronger the field. So immediately around the bar magnet here is where it's the strongest. And you can even see, like right around the poles here, it's a lot stronger than it is even right here. Okay, because it's kind of transitioning from one side to the other. All right, the next question on your sheet was check the Show Earth Planet box. So that is planet Earth. And then click and drag a sensor around the Earth. Where is the field the strongest? Okay, so we're going to kind of do the same thing. We're going to bring this around. So to the right, or I guess to the east of our planet here, you can see that it's 0.25. If I bring it over to the other side, it's about the same, 0.25. And let's bring it up to the top. 1.6. We'll bring it down to the bottom. Can't even see it down there. Let's move it right about here. Up. One of the limitations of the simulation here. Okay, so again, just like with the bar magnet, the planet Earth kind of follows the same pattern. The magnetic field is stronger right above the poles here. Yeah, so I'll get to chemistry at 1:30 and I'll transition over to doing some multi-step calculations. Okay, I do physics for the first half hour of my live stream, and then I'll switch over to chemistry, and we'll do some multi-step calculations. Okay. Yeah. So 1:30, I'll switch over to chemistry and start talking about the chemistry material. So if you want to come back, you can, or if you want to stay and listen to the stuff we're working on in physics, that's up to you. Okay. All right. So the other question was about the electromagnet. Okay, and this is what we're going to be conducting our lab with. Okay. So an electromagnet involves a battery, and basically you're running a battery through these wires, and it's inducing a magnetic field. Okay, so like you maybe heard the term inducing with like child labor. So it's basically causing it to happen. Like you're inducing labor, you're causing childbirth to happen. So you're kind of like forcing a magnetic field here. Okay, so that's what the battery's doing. You're inducing a current. You're inducing a magnetic field. Okay, so on the simulation here, the question that you're supposed to answer for today was just what's one interesting thing you observed while playing with the electromagnet. Okay, so we're going to start a lab activity tomorrow that's going to be looking at the electromagnet here, and you're going to be trying to figure out what the relationship is between the strength of the electromagnet and the voltage, and then the strength of the electromagnet and the number of loops. So you can adjust the voltage of your battery here by dragging the slider. Okay, so as you drag the slider, you can kind of see a little bit of change here on the outside. It might be hard for you guys to see on your screen. I can see it. It's very faint. Okay, so like if you look at like this one right here, watch it as I start to change the slider. You can see it kind of changing a little bit. And then you can adjust the number of loops here. Same kind of thing. If you notice the compass icons, they change brightness as I change the number of loops. Okay. Now, we are able to measure the strength of the magnetic field using a field meter. So what you're going to be doing in the lab activity to get some actual numbers is to take the field meter and you're going to plop it down right on the coils like that, and you're going to adjust the voltage, and you're going to adjust the number of loops. That's pretty much it. Hey Sarah, how's it going? Sarah, you are so lucky because you get a preview of a video that's going to be posted tomorrow. It's like a sneak preview. Like you know, when you go to the movies and they have those secret release parties, like midnight releases. So you're gonna be one of the first people to see this. So let me find this video, and I'm gonna link it in the chat here, and I will play it as well. All right. So this is pretty cool that you get to see this. Here you go. There's the link, and then I'm also gonna show the video right now too. I filmed this morning.
The strength of the battery.
Oops. Let me go back.
In this video, we're going to explore how the strength of the battery and the number of loops of wire affects the strength of our electromagnet.
This is only like 2 minutes long.
So what I've done is I've taken 3 bolts and I've wrapped the wire around 10, 20, and 30 times. And we're going to explore how the number of loops affects the strength of our electromagnet. So I have 2 batteries here. I have a C battery and a much bigger D battery, and we're going to explore how the strength of our battery affects the strength of our electromagnet. To build my electromagnet, I'm going to take the wire and I'm going to tape the negative end with a piece of wire. And then I'm going to take the positive end, and I'm going to do the same thing. I'm going to attach it with a piece of tape to the positive end. just like that. Next, I'm going to take my electromagnet and attempt to
This
pick
is
up
so
some paper
cool.
clips.
Huh?
I've got one.
There's two. I didn't count them every time. Look at that. That's what? 5? It's pretty cool.
Let's repeat the process, but let's use a D battery instead.
Didn't notice I switched to Duracell for the D battery. So there's 3. That's 3. That's 6. That's looks like 8.
So what did we learn from our investigation? What did you notice about the number of loops and how it affected the strength of the electromagnet? When we switched to a larger battery, what did you notice about the strength of the electromagnet?
All right, so look at that. You got a preview of the awesome video you get to see tomorrow. But I'm going to take a couple minutes and I want to show you some other cool things that will happen with these. And I think I may have shown some of this the other day when we were doing our live stream, but that's okay. So, a couple things. Yeah, so I had an Energizer D battery and it was not working. It was terrible. So I did switch to the Duracell battery during the video. Most people won't notice that, but you can point that out to your friends when they're watching the video. Okay. So the cool thing about these electromagnets is you have to have a magnetic, or sorry, you have to have an electric current flowing through them for the magnet to work. Okay. So let me see if I can figure out the best way to do this. I can just bring it up to the camera. All right, so I'm going to use the really strong one. I'm going to use the 30 loop one here. This is exactly what we're doing in the FET simulation, but you will get to see it with the actual equipment tomorrow in the video, or actually today. You get to see it today. So let me take my C battery and grab my tape. Okay, so I'm going to tape this up just like I did in the video. So I'm attaching one end of my wire to the battery here, and then I'm going to take another end and I'm going to attach it to my battery. It takes a lot of skill to be able to do this, let me tell you. All right. So we are attached here, just like that. So I have a paper clip. I have my battery all hooked up like this. Let's see if it holds. Right? So it works. Now, watch what happens if I disconnect one of the wires. Oops. I think it just kind of came loose. Let's try that again. So there we go, crack the tape. Okay, so here's my electromagnet, and so I got the paper clip on, and then if I loosen the wire, you see that it falls right off. Okay, so you have to have that current going through here for the electromagnet to work. Right? It sticks, and then if I release it, it comes off. So, pretty exciting. Now, if I take the bolt off completely, so no battery, right, and I take my paper clip, notice the paper clip does not stick anymore. All right, so let me hook it up to the battery one more time. And you'll see that you have to have a current flowing through your battery, through your wire rather, for this to work. So Sarah, you said you want to do that. So find a battery at home. You can pretty much do this with any battery. The bigger the battery, though, the better it's going to work, you'll see, or as you saw in the video. So again, I got this all wired up. Oops, I don't think the wire's touching. Now, getting a wire might be a little tricky at home. So again, here we go. It's like magic, right? Ta-da! Tell me that wasn't worth signing on to YouTube for right there. So getting a wire might be hard if you're going to try this at home, because you need to use a thinner wire, and it also has to be, for this to work properly, you want to make sure that it's insulated. So like this. It might be difficult to see on the camera, but if you look really close, let me try to put something behind this. Stand by. I gotta find an index card. I'm loving it. I'm gonna go get McDonald's. Alright, so if you look really close at the wire here, let me get this in the right spot, you can tell that, you see that where the orange is, that is where there's something covering the wire, and then just above it you see it's got that like copperish color to it. That's the actual wire itself. So your wire has to be insulated like this. If you just have bare metal wire, it won't work. Okay, so the simulation here is a little misleading, because in the simulation it looks like it's all just like the same thing, but for an electromagnet to work properly, you have to have insulated wire. Okay, you can't just have like copper wire going around this. Okay, so Sarah, if you're going to build this, that would be super awesome. I don't know how you're going to be able to find wire at home, but you never know. I had to take a network cable, an Ethernet cable, like, grab one of these, like one of these, you know, that you plug into your computer. I took one of these apart to get the wires out. There's 8 little tiny wires in these. But if you had like an extra phone cable, you could take that apart. You could strip it. It would take a lot of work though. If you do it, that will be super cool. You should totally post a selfie with your electromagnet and tag me on Twitter, because that would be really cool. I would, I don't know, I would figure out something cool to send you if you were able to build your own electromagnet with stuff at home. You should make that a project. You should have Daniel help you. Daniel's my one of my favorite chemistry students. Okay, I think you and Daniel could probably figure it out. You could probably make it happen. Okay, Sarah, are you taking chemistry next year? I really hope that you are, and I really hope that I get you in chemistry. Because bet, what does that mean? Is that yes? Does bet mean yes? I'm going to put a request in to get you for chemistry, even if you're not signed up for it. I'm going to make them sign you up for chemistry, because you were an amazing physics student, and I feel like you're going to be an amazing chemistry student. So I'm going to email somebody right now and tell them to sign you up for chemistry. So anyway, so yeah, that's pretty much what we're doing tomorrow. Tomorrow you're going to have to write a methodology for your investigation. So you're going to pick to either look at how the strength of the battery affects the electromagnet, or how the number of loops affects the strength of the electromagnet. Okay, so it's really, really easy, really simple, because you're just basically putting this here to measure the field, and you're going to either adjust this, and look, you see the numbers changing right now, or you adjust this. You see the numbers changing? That's it. And then you just have to kind of explain what's going on there, okay? So just like the other investigation that we did, it gets broken up into chunks. You'll do a little bit each day, and then that's it, okay? Sarah, I have to say I've been super impressed with you. You are one of the few physics students that has been doing all of their work and checking in every day. You are amazing. Are you going to join me on Zoom at midnight on Friday morning, or are you going to be asleep? I think you're asleep right now because you're not replying. All right. Well, I'm going to pull up my OneNote, because I did have somebody pop in a few minutes ago that was asking about chemistry. So I'm going to go through some chemistry practice here in a minute. Did you have any other questions about the stuff that we did today? Absolutely not. Are you saying absolutely not to not being asleep, or to not coming to the Zoom meeting? Oh, you know what? I saw something kind of cool that just came out. Let me pull this up. Apple, because like everybody has an iPhone, Apple just released a brand new iPhone today. It's the iPhone SE Special Edition, and it is only $400. Super cool, right? Because who wants to spend $1,000 on a phone? It only has one camera, so like I have the 11, which I would have totally gotten this phone if it was out when I had to replace mine. So like the 11 has two cameras, this one only has one, and it's got the button instead of the Face ID, which I hate the Face ID. It never works for me at nighttime. All right, I know it's supposed to work in the dark. I've added my face like a dozen times, and it still doesn't recognize me in the dark. I don't know what I'm doing wrong. Maybe it's the facial hair. I don't know, but it doesn't recognize me. So that was super exciting. And the other thing that I noticed too, this is super silly. They're really high end computer. It's called the Mac Pro. Um, they have a $700 kit to add wheels to it. So this is the Mac Pro. It looks like a big cheese grater. Looks like this, right? So this is their computer. Like they're ridiculous. Like they're $5,000. Like insane, right? How expensive they are, and they're charging $700 to put wheels on the bottom of them. It's crazy, right? So yeah, I will stick with my Mac that I have. Check this out. This is my baby right here. Look at this. Huh? It looks just like me, right? This thing's adorable. This is from 1988. This thing is a gem. This thing probably cost a fortune when it came out. All right, I got this at a flea market, and everybody wants one now because Apple's cool again. So that's my story, and I'm sticking to it. So with that, I will get ready to do some chemistry. Sarah, it was a pleasure having you today. Let me put this back up here before I break it. I need to bring that to school. I feel like it would get more appreciation at school than it would sitting on top of my desk. Okay, so let's see. I don't know. Someone popped in earlier that was looking for help on the three-step equations. Is that person back on? Because I can wait a minute or two for that person to come back. Guessing they're not here yet, which is fine. So we'll wait a couple minutes and then I will get rolling here. So the question of the day is, if they were making a movie and you were supposed to be in it, if you could pick a celebrity to play you in that movie, who would you pick? That's the question of the day. So if you could pick a celebrity to play you in a movie, who would you pick? And again, I know I have somebody that was asking about three-step equations earlier. Is that person back on? Fortunately, I don't know who's here or not. It just tells me how many people are watching me. So in a couple minutes, I'm going to go through some more multi-step equations. I'm actually going to do the other set of practice that I was going to do yesterday, but nobody showed up for chemistry yesterday. So we didn't end up doing those, but I'm going to do those today. If you're going to follow along with me, it's in OneNote. It's under homework, and it is the multi-step calculations number 2. So we're going to spend some more time going through those, and I'll answer any questions you guys have. All right, but I'm going to get started at 1:33, let's call it. So I'll give everybody that's coming back for chemistry an opportunity to jump on. And while we are waiting, I'm going to reply to a few emails. Looks like New York is requiring residents to wear a mask or mouth and nose covering wherever they are unable to maintain social distancing. I feel like that should have been something they did from the beginning. Who knows? I'm getting so tired of this pandemic. Okay, so in about 2 more minutes, I'll start on these multi-step examples. I just want to make sure that that person that came in during my physics is back on, so they don't miss anything. I'm going to record this and post it to YouTube, so if you're watching this later, you can just skip ahead another probably 2 minutes, and then we'll get going. Oops. Let's pull that back over. Okay, so I'm going to go ahead and get started. Hoping that person that was looking for me earlier will jump in. If not, this is recorded, so you can just jump on later and pull up the stream and go through it. So the question of the day is, if you could pick a celebrity to play you in a movie, who would you pick? I've got one viewer. They've been awfully quiet this whole time, so I'm just going to tell you mine. Mine would be Bryan Cranston, who plays Walter White in Breaking Bad. So you can see a little bit of resemblance here, right? He's a lot older than I am, and his goatee comes in a lot better than mine. Mine, it hasn't quite connected down here yet. His is a lot fuller. So, yeah. I also don't own a pair of glasses that look like his in Breaking Bad, which I should probably get those, okay? So that's who I'd want to play me in a movie. So let's go through the schedule for this week. You were supposed to have gone through multi-step calculations, which I'm going to review again today. Today the quiz is open on Mastery Manager, which is for you guys the Safe Exam browser. So go through and take that when you're ready. You're going to have the rest of the week to do that. We're not doing anything else this week. So please use the rest of the week to take that quiz. The practice that we're going to go through today is in OneNote. So if you want to follow along with me, you can. Or if you did it already and you want to kind of check your answers, it is in OneNote. The calorimetry lab is due today. I didn't have anybody ask me any questions about it, so I'm going to assume that you all know what you're doing. If we get to the end of the practice and there are questions about the calorimetry lab, I can pull mine up and I can go through it. And then the only other reminder that I have for you guys this week is Friday at midnight, we are doing our Zoom check-in. I've had a lot of people tell me that they're sleeping during the day and awake at night, kind of like the vampire thing, you know. So I thought I would give it a shot, and I would host a Zoom check-in at midnight on Friday. We did an astronomy stargazing party last week at 3 in the morning, and we had 15 people show up. So I thought, what the heck? Let's give it a shot. So let's do this. If you want to follow along with me, you can. If you're checking your answers, you know, whatever you want to do. Or if you just want to watch me, that's fine. But the problems that I'm going to be working through, the multi-step problems that I'm going to be working through today, you can find them in OneNote under Homework, and then it's Multi-Step Calculations 2. If you're one of the people that are having issues with OneNote, you can also go to my website, and I'll show you exactly where they are. I think in the post I even gave you the link to the PDF, but let me pull this up. So if you are following along, you're going to go to Classes, Chemistry, or actually, sorry, it's under eLearning. So eLearning, Chemistry, and then this is the code for the test. This is what I was planning on doing these problems yesterday, so it's actually on yesterday's post, But right here it says here is a link. If you click on that link, it'll bring up the PDF version of the Leo or Brad Pitt. Like Leonardo DiCaprio would play you. I could see that. I think Brad Pitt would be a better pick for you though, Nolan. I think you bear a striking resemblance to him, or he bears a striking resemblance to you. So I'm not grading this, but if you want to do the problems on another piece of paper, you can pull up the PDF version, and then we are going to go through numbers 7 through 10 today. So that's basically it. I feel bad that so many people are having issues with OneNote. I really wished that it worked more consistently for people because it's got handwriting, and Google Classroom does not have handwriting input, which is the only reason I don't use it. The day they put handwriting input into Google Classroom, I will totally switch over and use that instead. Okay, so let's go through this. I'm going to pull up my OneNote on my screen here so we can do this together. Let me maximize this up. Okay, so no, I don't think so. I don't think Matthew McConaughey or Clint Eastwood would be good choices. I really think Brad Pitt would be a good fit for you. Hey Grace, how's it going? Did you get my email about chemistry? Everything good to go now? Nolan, you should see Grace's calorimetry lab. I teared up a little bit when I was looking at it. It was just phenomenal work right there. And I made sure that her mom knew it because it was awesome. All right. So we're gonna go through the multi-step calculations here. First thing it wants us to do is draw a cooling curve. So a cooling curve, we are starting as a gas. Well, I haven't graded them yet. They're not due. Today is when they're due, so I'll grade them tomorrow. You still got time to jazz it up. You should talk to Grace. She can tell you how to make yours look awesome. All right, so let's do this. It says draw a cooling curve for a substance with a boiling point of 160 and a freezing point of 90. This is a blank graph. So the first thing we need to do is we need to label our axes. I'm going to label the x-axis energy, and the units of energy are joules. And then the y-axis is going to be temperature. Let's see if I can do this sideways. And the units of temperature are degrees Celsius. Okay, it says the boiling point is 160 and the freezing point is 90. So what I'm going to do is I'm going to draw a line across my graph, and I think I can actually do this with a highlighter. So 90, or actually I need to put, I'm skipping ahead. I need to put units on my axis. We know that we want to leave space below our freezing point and above our boiling point. So let's see, we go up to 160. So why don't we, let's see, why don't we do 40 above, so that would go to 200 degrees Celsius, and 40 below, so that would start at 50. So we need to go from 50 to 200, and then there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's 15 boxes. So let's make each one 10. It's perfect. So we'll start here at 50. I'm going to skip a line, so I'm going to skip a line, so that'll be 70, 90, 110, 130, 150, 170. Let's see, 60, 70, 80, 90, 30, 50, 70, 190, and then 200. Okay. So again, you want to, when you're drawing your axis out, you can do this. You could have done this a couple different ways, as long as you leave space below your freezing point and above your boiling point. Okay, because you don't want to have just like two flat lines at the top and the bottom. You want to leave space to see where it continues on. Yeah, that's kind of unfortunate if you lost your stylus. You can use your finger. If you click this button right here where it says draw with mouse or touch, you can use your finger. It's not the best, but it's what I got. It would be awesome if you could use just like, you know, a pen like this and just use the other end, but it doesn't work like that. All right. So where do we leave off? Okay, so now let's draw in our points. So we have a freezing point of 90. So I'm going to take and go across my graph. So that's 90. And then our boiling point is 160, which is right here. And if I'm going too fast or if you have questions, you don't understand how I did something, just stop me. Okay. Next, we are going to draw in our curve. Okay. So we know our cooling curve. So since we're cooling curve, we're starting as a gas. We're going to go down to a liquid, and then from a liquid, we're going to go down to a solid. So we're cooling down. So I'm going to draw my curve like this. Oops. Ugh, I messed up now. Okay. Anywhere on our graph where we have a diagonal, we are changing temperatures. Anywhere there's a plateau, a flat part of the graph, is where we are transitioning phases. So I'm going to throw some letters in here. So we are starting up here as a gas. This is where we're a liquid. And then, oops, liquid. And then this is where we are a solid. All right. Again, anywhere we have a plateau, so like here and here, is where we are changing phases. So let me throw some other letters in here. So this will be, let's call this, my OneNote is not cooperating. We'll call this segment A, this will be segment B, segment C, segment D, and then segment E. Just so when I'm talking about the segments, you know what I'm talking about. All right. Any questions on how I drew the curve? You don't need to tell me what part is the gas. You don't need to like use different colors. You don't have to put the A, B, C, D, and E in there. That's just for me to help explain what's going on. The requirements that you have to be able to do here are label the axes. So the x-axis is always going to be energy. The units are going to be joules. You can also do reaction time, and the units would be seconds, but energy is usually the go-to. The y-axis is going to be temperature, and the units of temperature are always going to be degrees Celsius. You do not need to put any numbers on the bottom here. On the y-axis, you need to make sure that you space everything out kind of evenly. All right. You don't need to start at 0. So if you notice my graph here, I started at 50. You don't have to start at 0. Okay. The only requirements when you draw this is that you read the question and it tells you like my freezing point is 90 degrees. So what I did is I drew a line across my graph at 90 degrees. And you want to make sure that you've got some space below that so you can show the solid state below that. And then my boiling point was 160 degrees. So you want to make sure that you leave space above that on your graph so you can show the gas state. So if I didn't have those, my graph would kind of look like this. It would be flat, a line, and a flat. So you would really only be showing the liquid state at that point. So we want to be able to show all three states. So that's why you want to leave a little bit above and below. All right. So nobody's typed any questions, so I'm going to move on to the actual calculations. So in this example, it says to label where the graph is a solid, liquid, and gas. So we already did that. It says label on the graph where are the phase changes. Okay, so segment B on my graph here is where we are transitioning from a gas to a liquid. So this point right here is where we are a gas starting to turn into a liquid. The second point here is where let me actually label these with numbers. So point number 1 is where we are a gas turning into a liquid. Point number 2 is where we've totally turned into a liquid. point number 3 is where we're a liquid starting to turn into a solid, and point 4 is where we've totally turned into a solid. Okay, so if we were doing this the way the directions told us to do this, we would be phase changing here. Hey, how's it going? Why are you so depressed? Is it the snow? Oh, and Grace, I understand that you're going to be moving soon. Your dad posted something on Twitter about having to move if you have to use the snowblower and the lawnmower in the same week. So I would recommend South Florida or Hawaii if you can afford it. Hawaii is awesome. All right. Number 10 says how much energy is needed to cool 7 grams of gas at 180 degrees to a liquid at 100 degrees Celsius. Right? And the question tells us that this is a 3-step problem. So I'm going to erase a few things on my graph just to simplify it so you can see what's going on here. So let me erase this and this. And this. Okay. Hey, Dean, how's it going? All right. So it says we are a gas at 180 degrees. So let me pick a color. Let's do this like fuchsia color. So we're going to start at 180 degrees, which is here. And we want to go to a liquid at 100 degrees, which is here. All right, let me zoom in a little bit so you can see that better. Because this is important. This is, I think, where most people are getting confused on this. It's not understanding where the steps are coming from. All right. So the reason this is a 3-step process is because we are going to be on 3 different segments. So we're starting here at 180 degrees. The first thing we need to do is we need to go down to this point here. So we're lowering the temperature of our gas. That's step 1. Step 2 is we're going to go from a gas to a liquid. So we're going to go from this first black point here to the second black point here. At the second black point here, we are now totally liquid, but our liquid temperature is 160 degrees. The question wants us to lower the temperature of our liquid to 100 degrees. So that is our 3rd step. So then we go down to here. So again, first step here, second step here, and then 3rd step is all the way down here. Okay. So let's take a look at the problem. Down here at the bottom, it gives us the givens, which you're going to need to answer this. So let's do our first step. So we need to take our gas and we need to lower the temperature. So we'll call this part, we'll call this part A. Come on, OneNote. I get just as frustrated with this as you guys do. All right, so part A. Let me get a smaller pen. So Q equals MC delta T. This is the equation anytime we're raising or lowering our temperature. Q equals MC delta T. The C value comes from whatever state you're currently in. So at the very top here, we are in the gas state, so we're going to use the C value for the gas. That's this one right here. We're going to use the C value for the gas. So let's plug it all in. The mass of our sample is 7 grams, which is in the question. So 7 grams times the C value, which is 1.0 joules over grams degrees Celsius. And then the change in temperature. Again, the change in temperature can be confusing as well, because right here in the question it tells us we're going from 180 degrees to 100. So you might think, well, that's a difference of 80 degrees. You're right, but for this specific part of the problem, we're only looking at the temperature change from here to here. So the temperature change from 180 degrees to 160 degrees, which is that point right there, is only a difference of 20 degrees. All right, so on your calculator, 7 times 1, which is 7, times 20 is going to be 140 joules. Okay, and another confusing part about this is a cooling curve. So we're losing heat energy. Anytime we're losing heat energy, that is exothermic. We're releasing energy into the environment. So that would be a negative value there. Okay, so think about it. If you took a pot of boiling water outside on a cold day, you see all that heat energy being released. Okay, it's kind of warming up the air around your pot outside. Okay, you can see the steam coming off. All right, so kind of the same thing's happening here. All right, we're releasing heat energy, so our temperature's dropping. So we want to make sure that we include a negative sign anytime we're on a cooling curve. Okay, let's look at the second part. So the second part, we are going from a gas to a liquid. So we're on this plateau right here. Anytime we are going to be transitioning from a gas to a liquid or a liquid to a gas, we use the heat of vaporization. So our Q is going to be equal to the mass times the heat of vaporization. These are a little bit easier because there's only two variables. So the mass is 7. The heat of vaporization is given in our table right here as 5,630 joules over grams. We're not changing temperature here, so there's nothing to add on here. Excuse me, there's nothing to add on here. So 7 times 5,630 gives you a value of 39,410 joules. And because this is exothermic, we're releasing heat energy, we want to make sure that we include that negative sign right there. All right, not done yet. We have a third part. So first part was here. We lowered the temperature of our gas. The second part was transitioning from gas to liquid. The third part is lowering the temperature of our liquid to reach this final point down here. So for part C, anytime we're lowering or raising a temperature, it's Q equals mc delta T. Our mass is 7 grams. The C value is whatever state we're in. So at this point, when we're lowering our temperature, we are in the liquid state. So we want to use the C value for a liquid, which is right here. So 2.5 joules over grams degrees Celsius times the change in temperature. And again, we're not looking at the overall change in temperature. We're not looking at the 180 to 100. We started here at a temperature of 160, and we're dropping down to a temperature of 100. So 160 to 100 is a difference of only 60 degrees. All right, so 7 times 2.5 times 60 is negative 1,050 joules. Okay, to get the total amount of energy that it took to go from here to here, we just add up the three energies. Okay, so I think the analogy that I gave on Monday was like Google Maps. When Google has to figure out the distance to go from Joliet to Chicago, it's figuring out how long you're on each individual street, and then it adds up those distances. It's not just a straight distance to Chicago. It's got to do all the individual steps. So this is kind of the same thing. So we need to figure out how much energy it took to go from here to here, how much energy it took to go from here to here, and then the final one, how much energy it took to go from here to here. So we're just adding these three numbers up. So 140 plus 39,410. And then 1,050, we add those up and we get 40,600 joules. Okay, and the reminder that I'll give you on all of these, anytime we're on a cooling curve, don't forget to include your negative symbol. Okay, so let me just make a note on here. Cooling curve. Whoops, can't spell. curve equals negative energy because it's exothermic. What questions do you have? So there is a quiz for you guys to complete on Mastery Manager, which is Safe Exam Browser. The codes I pushed out to you on my website. So just make sure you're using the right code for your class. It won't let you in if you're using the wrong code. And it's just like in school, you know, it'll pop up. It will close everything out of your computer. The other way you can do this without having it close out of your computer is to use examlogin.com. If you go to examlogin.com, let me write that down. So if you go to examlogin.com, which is the other way you can take this, if you go to that website, same thing like if you're using Safe Exam Browser, you put in the code, you put in your student ID, and it'll let you into the test, but it will not lock you out of your OneNote. So if you want to take it and be able to look at your notes, use Exam Login. Otherwise, if you use Safe Exam Browser, remember it's going to lock you out of everything on your computer. So if it were me, I would use Exam Login because you still have access to your notes. Okay, we have no way of monitoring you guys when you're using the software. Could you cheat on it? Sure, but what are you going to get out of that if you cheat? Okay, the stuff that we're doing on these graphs, all of the heating and cooling curves, graphing is definitely on the SAT. So I'm not sure what's going to end up happening with the SAT, but you need to be able to read a graph and interpret a graph. So like this skill that we're working on right now is definitely something you're going to see again, okay? Whether it's on the SAT, whether it's in a college chemistry class or another science class, being able to interpret graphs is important, okay? So unless you guys have any other questions, I'm going to wrap up for today. I just want to remind everybody that we are doing a Zoom check-in this Friday at midnight. So if you want to join me, you can. A lot of people have told me that they're sleeping during the day and awake at night. So I'm like, hey, why not? Let's try it. So I'm going to be doing it at midnight on Friday morning. I'll email you guys the details again. So if you want to pop in and do that with me, you're more than welcome to. There's no science or anything that we're doing. We're just going to kind of hang out. Mr. Jern is doing a Minecraft world with his kids. So and then I also know Mr. Zwartz is playing Fortnite. He created a separate Microsoft account just to play Fortnite with his kids with. So I'll have to think of something cool that we could do along those lines. If you guys have any suggestions, I'm certainly open to it. But I played. So let me show you guys this while you're still here. I'm so excited about this. This happened to me 2 nights ago. And if you were here yesterday, I told everybody yesterday. Check this out. I'm so proud of this. Let me pull it up. Why is it pulling my albums up? I don't want albums. Stand by. It's going to be worth the wait. Look at this. Boom! My son is absolutely insane on Fortnite, and we were playing squads. He invited me and then 2 other friends to play, and he pretty much carried me through that game. All right, I wish I could take some credit for that. I actually died during the game, and he picked up my I haven't played in a long time. He picked up my card or whatever, and then went to the bus, the reboot van or whatever it's called, and brought me back. So I actually didn't really do anything. I was just kind of on, but I got credit for it. So it's awesome. All right, so I will see you guys tomorrow if you're going to jump on. If you do come tomorrow during the YouTube, we're just going to do some more practice. Remember, you guys have the rest of the week to finish that quiz. We're not doing anything else until next week. I'm going to make sure that you guys have this, and that's pretty much it. So I'm going to go ahead and sign off. I will see you tomorrow. Don't forget about the Zoom call. Cool. I really hope that even if you don't know people, you should just drop in because it's awesome. And Grace, actually, while you're still here, so this is super weird. We were doing this astronomy club stargazing thing last week. It was at 3 in the morning, and I posted a picture of it to Twitter. Like, no joke. Posted it at 3 in the morning on Twitter, and your dad liked the post at 3 in the morning. Why was he awake at 3 in the morning, and why was he on Twitter liking tweets at 3 in the morning? It just seemed a little odd, but You never know. All right. There's definitely nights where I'm up and can't do anything, and I'm not gonna lie and tell you that I don't jump on Facebook or anything. But just like, what are the chances, right? Anyway, I'm gonna sign off. It was good to see you guys. I'll see you tomorrow. If I don't see you tomorrow, I hope to see you